today. Yesterday, yesterday we discussed DOE with the two factors, right? With the two factor, one output variable. The output variable in DOE is known as response variable. The input factors are known as predictor variable, right? So there were two input factors and one response variable. The response variable was adhesive strength. The predictor variables are primer and painting method. And primer, we had a 3 primer. So the level of the first factor is 3. And the painting method, we had 2 painting method. And so the level of the factor painting method is 2. So 3 into 2, 6. 6 treatments. We compared 6 treatments and found one out of the 6 as the solution for our problem, which was primer 2 and then spraying, I believe. Okay. So this is how hereafter you have to take a call. Whenever you wanted to optimize your factor, you first of all have to understand how many combinations are possible. Let me say there are 4 factor, each at 2 level. 4 factor, each at 2 level. Now, how many combinations are possible? How many treatments are possible?
8 treatments are possible.
Now, you have to do the max, Do the
Sir,
math. 4 factors I said, each at 2 levels. So what will be the total combination?
so there are L1, L2, L3, L4, each 2. So it is 2 power 4, 2, 2, 4, 8, 16 treatments.
Then why did you say 8?
I
There
actually
are
multiplied with factors instead of
16,
levels.
16
16
treatments
combinations.
possible. So minimum 16 experiments you have to do and apply the principles of DOE. There are 3 principles we discussed. First principle is principle of replication.
Application.
So then principle of randomization, then principle of blocking. Already there are 16 experiments. And if you go for replication of 2, then it will be 16 into 2, 32 experiment you have to do.
32.
Now, after doing the 32 experiment, your question is, which is the best out of the 16 options? Which is the best out of the 16 options? And that one out of 16 is going to be the solution, right? This is how you must be, hereafter making decision whenever you deal with multiple factors, right? Now, yesterday the interaction was not really significant, but today I'm going to show you another case study where interaction is going to be significant. If interaction is significant, we will ignore the main effect, but optimize the process for interaction effect. Okay, so that is the point. Now,
So can
let
you
us,
repeat? We
yeah,
when the interaction is positive, then
now when the interaction is significant,
significant.
significant means the p-value will go below 0.05. As the interaction becomes significant, p-value goes below 0.05. Now the factorial plot. Yesterday we have seen 2 factorial plot, right? The left,
Right.
one on the left, one on the right. The left is main effect, the right is interaction effect.
We skipped
When
interaction effect
interaction is
because the
significant,
yeah.
we turn off that and derive the solution only from the main effect. When the interaction becomes significant, we turn off the main effect and solve the problem for the interaction. This is the idea, right? So today we are going to see another example where interaction will be significant. And the case is, again, it is, let me say, this is an electronic manufacturing company. A PCB board, a PCB board, printed circuit board scenario. A company is manufacturing, PCB boards. The problem is some of the boards do not have the accurate dimensions. There were a lot of machining happens in the manufacturing of the PCB boards. One of the machining operation is drilling. They have to drill a hole, right? And now they were using a drill bit, and drill bit runs at 2 different speed. You can do the drilling at a lower speed as well as at a higher speed. And another thing is they can use the size of the bit. The size of the bit can be 8 mm or the size of the bit can be 16 mm, right? One is the size of the drill bit, another one is the speed of the drill. So there are 2 factors. Ultimately, what is expected? The expectation is dimensional accuracy. Now the team realized the dimensional accuracy is purely a function of the vibration because They always choose, the correct, what do you call, the sizes and other things. But even though the correct sizes are set, still the dimensional accuracy is not coming. And they realize that it is because of the vibrations that is happening. So they decided to control the vibration, because if you control the vibration, automatically the dimensional accuracy will happen. So the vibration is the output variable, the response variable, and drill bit size is one factor, drill bit speed is another factor, right? So with that, situation, situation, we are going to optimize the process. When we say optimize the process, our idea is to minimize the vibration. What is the requirement? Minimize the vibration. So let me share the screen. I'm sharing the screen. So I again, as usual, I opened the sigma level calculator file. I opened it. Yeah, I opened the sigma level calculator file. And here there is a sheet named vibration. You can directly see, isn't it? You see the vibration. See here, already the factorial design is made readily available. Can you see here? Standard order, run order, point type, block, bit size. Bit size means drill bit size. Bit speed means, the drilling machine speed, 40 RPM and 80 RPM. And vibration is measured in cycles per second. I copy all of these things, Control C. Now I go to Minitab. I take it to Minitab. I
In
place
the
my cursor.
data, there is only one block available.
You can see. Very good. In this case, they are able to complete all the 16 experiment in one block itself. That means one day itself. It's an experiment of, let's
Okay,
say, 10 minutes, 15 minutes. So they could finish everything in one day.
same day.
So blocking is not required.
Okay.
Okay. So keeping just one block is another way of, ensuring your block, is homogeneous. That's all. We are not testing, conducting experiment at different, timing. So everything is done, on the same conditions within the same day. So that's why block is one. If block is one, then there is no issue with the blocking.
Hmm.
Okay. So now I just copy pasted everything. And here, what is your y variable?
Minimize vibration dimensioning. Yeah, see,
And one factor x1 is
size of drill
bit size. And how many levels it has got?
2,
Yeah, one
8
is
and
bit size
16,
is 8 mm, other one is, 16
16.
mm. And another factor x2 is the speed.
8,
And as far as the speed is concerned, again, the level is
2,
2.
40 and
Here it
80
is 40 RPM and 80 RPM.
APM.
Now the number of treatments are going to be L1 multiplied by L2, which is equal to 2 into 2 equal to 4. Now replication. Replication in this case is 4. So total number of experiments will be equal to 4 into 4
To 4,
replication. So 16 experiment.
16.
So that's why you are seeing, 16 readings of vibration. Now you have to choose the one best value out of the 4 treatments. Totally, there are only 4 treatments. Best out of the 4. It's an easy job. It's like a square. Square has got 4 corners. Now you have to judge which corner is good. When I say square, you can easily understand. Square is like this. Now this is low and low. This is high and high. And this is high low. And this is low high. What do you understand out of this? X-axis is, let's say, speed, and this is
Size of bit.
size. Speed 40 here, 80 here. Size 8 here, 16 here. Now, what do you mean by low, low? 8 and 40 combination. What is high, high? 16 and 80 combination. Yes or no? That is what is called high and high.
Yes.
And you now know what is high and low. High means 80 speed, but then 8, is the 8 mm is the size. And the low high means 40 RPM, but the size is 16. So these are the four possibilities. And which is the best possibility we are going to do. And in this case, we already have, the factorial design. Now what we need to do is we just have to analyze. So tell me, at least you guide me. Where is the option I should go? Stat or some other point?
That,
Where the comes stat, right?
yes, sir. That DOE
AOE. Then
fac- factorial
factorial. Since the factorial design is already created, you can straight away proceed with analyze.
analytic.
But when you click analyze, Minitab, since this was not created by Minitab, it is asking you to define. Now let us define. Now, what are your factors? Bit size
Bit
and
speed. Bit speed.
speed. These are the factors. It's a two-level factorial. Both are two-level. You can call it two-level. So low, high. Bit size is numeric factor. See here, automatically it captured 816. Speed also 40, 80. Very good. Correctly captured. Now nothing is required. Now you can say okay. Now Minitab accepted. Now where is the response? Response is vibration. Now what are the effect you want to study? If you want to study only main effect, choose one here, which is called, the model order. I want to study the interaction also. So I choose two here. You see the interaction also appearing here. A, B, and A, B. Now I give OK. I give one more OK. Now everything is done. Now in this case, since the data is continuous data, the factors are continuous. You have got a Pareto as well. Now Pareto itself is telling you there is a red dotted line. You can see here red dotted line. All the three effects are going beyond the red dotted line, meaning all the three effects are significant. The main effect of A is significant, main effect of B is significant, the interaction effect AB is also significant. Which is most contributing? A is most contributing. Which is contributing next? AB. And which is contributing, last? That is B. Anyway, this is one way you can understand the significance. Another way you can understand the significance, you go to the ANOVA table. ANOVA table. Bit size. What is the associated p-value? 0. Is this significant? Significant or not?
Just
Bit
less.
size. Bit size is significant to vibration or not? Come on, all of you, please respond. P-value for bit size is 0. 0 means less than 0.05.
0.05.
So the bit size is significant or not? That is my question. Come on, all of you speak out. If p-value is less than 0.05, the factor is significant or not? If significant, type
Significant,
yes.
sir.
Then you have
Significant,
to
sir.
respond. No, respond. Maybe all of you, you can now type. Please type, whatever I'm telling. Since p-value is less than 0.05, bit size is significant. Can you please type this statement, all of you? I have typed it for you from my side. Since p-value is less than 0.05, bit size is significant. We have studied this already, in hypothesis testing itself. All of you, are you participating? I see only Vignesh and then Harigaran following. Now Saravanan. Now Vikas, Sukumar. Okay, now 5, 6 people have responded. Very good. Now let us proceed with let us follow this practice. Now let us think about the speed. Now tell me, the speed is significant or insignificant? If you think it is significant, type yes. If you think it is insignificant, type I. Let's see whether you are able to understand the significance correctly. Very good. So far, so good. Those who shared their finding, all of you are correct. But your participation is very important. Some of you are not really, trying anything. And you have to try. All right. So now going to two-way interaction, right? Going to two-way interaction. Now please look at the row and tell me whether interaction is also significant or not. The two-way interaction, is it significant or not? Come on, as usual, you all can type. Look at the screen. I have highlighted the interaction. Please find out whether the interaction is significant or not. Significant means as usual, type yes. Insignificant means type I. Not a difficult job. Significant means capital S. Insignificant means capital I. So now in this case, both main effects are significant. Interaction effect also significant. Great. Now what should we do further? We now should find out which is the best out of the four. For that, what should we do? We should go for a factorial plot, right? Listen here. Again, I'm going to start. I'm going to DOE. I'm going to factorial. Can you see factorial plot?
Yes, sir. Let's see.
Yeah. We click that factorial plot. We want to optimize for vibration. So vibration. Here you can choose, all terms, no problem. Then you just give OK. Now there is a main effect. There is an interaction effect. There is a main effect plot. There is also interaction plot. Now, in this case, interaction is significant. So you don't have to go through the main effect. You know why did I minimize that? Because interaction has become significant. So you have to derive your solution from interaction only. Now tell me, what is your objective with respect to the vibration? Vibration is represented in y-axis. What is your requirement? You
Minimize
want,
vibration.
you want to minimize the vibration. So choose the lowermost point. The lowermost point refers to usage of 8 drill bit and 80 RPM speed. Yes or no? So what is the best combination? 80 and 80 RPM. Bit size must be 8 and drill speed must be 80 RPM.
Yeah.
So under this condition, what will be the vibration level? So go to stat, go to DOE, go to factorial, come to response optimizer. That will help you to visualize your result. See here, your target now is vibration minimize.
Minimize.
Now you give OK, automatically it will minimize the vibration and give you the reading. See here, 8 and 80 RPM. You have to choose 8 bit size and then 80 RPM speed. Now, what is the max? What is the vibration level? 14.925. So this refers to 8. If you want to change it, you change it. You make it 16. If I change it 16, now what happens to the vibration? Vibration increases from 14 to 14 to close to 40.
Okay.
A huge, increase in the vibration. So, what do you call? Okay. So 8 is the best. 16 is not a best option. Do you all understand? 8
Yes,
is
sir.
the 8 is the best. Now coming here on the right side, which is speed. Right now it is 80 RPM. Now bring it to 40 RPM. When I bring it to 40 RPM, what happened to your vibration? 16. When I bring it to 80, it is just 14.98.
So this does not have a very huge impact on vibration, though.
Which one? That 40 and 80, yeah?
Yes, sir.
Yeah,
Speed
40
does
into
not have
40 into
16,
16.
14,
True. That we have seen in the
15.
interaction plot as well. You see, I'll show the interaction plot also. Are you seeing? There is not much, difference
Hmm.
between red color and blue color. Red refers to 80 RPM, blue refers to.
40.
No, you are
Yes.
very correct. There is not much, a difference in the vibration level, but there is a minor, difference.
Hmm.
Okay. So we were with the, the response optimizer. Now you can actually play and understand what happens when the RPM is 40. What happens when the RPM is 80. Totally, how many combinations are? Only four combinations, and we got the result. Hope all of you understand now the difference between yesterday's example and today's example. And today, yeah, it's again two-factor, two-level design. Okay. So now I go to stat, go to DOE, factorial. Let me predict. Let me predict what I want to predict. What is the bit size, optimum bit size? We understood 8. What is the good speed? 80. So in this situation, what will be the vibration? What is the vibration you are getting? What is the vibration you are getting? 14.925 cycles per second. And a small variation is expected. You see variation. It can go as low as 12.2 and the same can go as high as 17.5. Do you understand, all of you? Now, another advantage of the DOE and having the high quality data is DOE factorial. You can actually predict for any combination. Let's say 8, 10, 12. What is this 10 and 60? What is this 10 and 60?
In
10 refers to what? 10 mm
increase
throughput.
in bit size and reducing
Ah,
speed to
10
60.
refers to 10 bit size. 60 refers to 60 RPM. See, I am not actually conducting the experiment now. I'm only predicting, just with the help of the mathematical model. I am predicting the result. You see, for this combination of 10 and 60, the vibration is expected to be 19.67. Can you see that, all of you? Look at the setting, 10 and 60, and the fit is 179. That means vibration can be, oh, sorry, not 19.67. And however, it is expected to be in this interval. Are you following me, all of you?
So what is this CI and PI?
Good. CI refers to confidence interval. PI refers to prediction interval. CI refers to confidence interval. PI refers to prediction interval, which again means this 19.6719 is the average value of the experimental average of the vibration. If this is average,
Yes, sir.
the average the average is expected inside this confidence interval. If you don't do replication, if it is a single observation, then the vibration is expected to be in this. But that is why we carefully included replication, isn't it? So we
Yes, sir.
should refer to confidence interval. If you have
Hmm.
not done any, what do you call, the replications, then you must refer to prediction interval.
Okay.
You understand, all of you? Now, what is the
And
lowest vibration?
getting this
Hmm.
SE fit in the previous ones, I could able to see 1.22. On this new one, it is going to 0.68. What does that refer to?
Okay. So what is this? This is called standard error. It's called
Standard error.
standard error. Have you studied standard error earlier? Did you study the
I
standard error?
think we discussed about it in one of the classes. I don't recollect it, sir.
Yeah, yeah. See, the standard error helps in finding out this interval. What is this interval? Confidence interval.
Mm.
Standard error helps in finding out the confidence interval. So standard error is nothing but the standard deviation of sample averages, or otherwise, standard error is nothing but what am I writing? Standard error is nothing but S by
Square root of n.
square root of n. S by square root of n. So where S is standard deviation of the data. The data is vibration data. When you have replication, when you have the vibration data variation, you can calculate standard deviation out of it and divide the calculation by root of n. That will be your standard error. That standard error is used to predict confidence interval. The S value, the S value is directly used to predict prediction interval. So this
Okay.
confidence interval and prediction interval are nothing but the expected range for your average and individual outcome. So what is our
The
conclusion here? Vibration can be optimal at what? At
bit speed,
where the vibration is less. For
bit
8
size
and
of 8
80,
and speed 80.
uh,
Fine.
8 and 80, 14.925. But when I go for 10, see, note here, 10 and 60, I have not conducted any experiment. But after generating the equation, I am predicting it. This is the advantage of another DOE. The other advantage of DOE is, you see here, you have an equation. Can you see all of you? This is called regression equation. This is called regression equation. The regression equation can be used for prediction purpose, and that predictive power is very high, and the what do you call, the predicted vibrations are indicated in the form of confidence interval and prediction interval. Clear, all of you? Tell
Yes,
me,
sir.
do you have any questions here? How is it? How is this example different from yesterday?
The yesterday case, it was direct. There is no interaction is insignificant. Today, in this case, whatever we have seen, interaction is
Very good.
significant.
The previous case, interaction was insignificant, but now in today's case, interaction is significant. That is one thing. And another thing is our X variable is continuous variable here. You might have noticed. Speed and size. Speed and size are
Mm.
measured value. So that is why the prediction is possible. We have not done any experiment for 10 bit and 60 RPM. We have not done any experiment. But we still have some prediction available. Can you see that, all of you?
Yes, sir.
So what is the purpose of DOE? Not only optimizing your process, but also understand the mathematical model, which can be a representative of your process. Once you arrive on such a good model, then you no more have to rely on the process and then the data from the process. You can directly substitute your x values in the equation and the response variable, will be calculated. And for all such predicted y variables, we will have the prediction interval as well as confidence interval. Prediction interval is to predict next observation, but confidence interval is to predict. I'll tell you. I'll put in the chart box. So confidence interval will be certainly what is that? Okay. The point is, yeah, sample average. The sample average is expected to be expected to be the sample average is expected inside confidence interval. Do you understand, all of you? Sample average is expected to appear inside confidence interval. Next thing is individual.
Can you say it in different words? A sample average is expected inside CI. Okay, so the uh, predictive value that we are getting will be inside of CI range.
Exactly.
Okay.
I think now after reading, individual sample value is expected inside prediction interval,
Okay.
but sample average is expected inside confidence interval. Now there are two intervals available: confidence interval and prediction interval. Which interval is wider? Prediction interval is wider. Prediction interval is wider, but confidence interval is narrower. And so confidence interval can be used to predict what? Sample average. But prediction interval is used to predict individual observation. Maybe fifth part, 10th part, fifth output, sixth output, seventh output, whatever output. Are you clear, all of you? Tell me, have you understood how to deal with the DOE with the minute with the interaction? As DOE helps in helps in what is the question? Is DOE helpful in optimizing your process result? The answer is certainly yes.
Yes.
Yes, it helps in optimizing. So how should you optimize? Yes, you can use different prediction values. You put whatever. See, the advantage with the continuous X factor is do we have any drill bit in six? What is that? Other eight? Ama 8, 10, and 16. Ah, okay. Do we have the 16 drill bit readily available? Sorry, 10 drill bit readily available? No. But without even the conducting the experiment, we are able to predict. That is the advantage of having a regression equation. Clear, all of you? Or do you have any question to ask? Please feel free. Tell me.
Clear for me.
There are multiple methods I have taught you. You can look at factorial plot or you can look at response optimizer. That's the best method. Yes. And you can solve a problem for any number of factor. Let me see whether I can do one more problem for you, all of you. So one more case. So I'm sharing my screen. Hmm. Sabic. That is the Sabic example. Here, Sabic MFI example. Let me open this. It's loading. Taking more than the usual time. Sometimes. Oh God. Stop. Okay. After I close, very good. This is just opened. No problem. So I'm sharing the screen again, complete screen. Please confirm. Can you see another example of DOE? MFI, feed rate, speed, temperature. That's all. And then the blocks. How many blocks? One, two, four blocks. Interesting. Point type. Point type is still linear only. Run order, random order. Hope you all understand, right? And now what is the response variable here?
M of I. What
Melt
is
flow index.
okay?
X1 may be
Temperature.
temperature, and
It
X2
would
may be
be screw
screw speed.
speed. Yeah, yes, sir. Screw speed.
Then X3
Feed
will
rate.
be feed rate. Then X4 will be,
As
what is X4?
only no X4. We have only three.
There are only three. And now temperature, how many levels?
2,
L1 equal to 2. And then the screw speed,
same 2, 150 and 250.
then the
L
feed rate.
is also 2, 150 and 250. I
Okay. Just let us do a check, 150, 250, 150, I think you are correct. So it's 40, 60 fully. You're also correct. Temperature 250 to the 230. So now this is the thing, this is the limitation. We have done the experiment. Now we just have to analyze. Stat, DOE, factorial. Already the designs are created. So straight away go for analyze factorial design. Now what is your response? MFI. What are your terms? The terms are, first of all, now you choose this. Now see here, you have option to 1, choose 2, also choose 3. 1 means only main effect. 2 means up to
Okay.
two level interaction. 3
Sir?
means three-way interaction. Now I want to study everything. Three-way interaction. Okay. Terms. Yes. These are the terms. Temperature effect, screw effect, feed rate effect. Then A and B together. A and B means temperature and screw speed. A and C means temperature and feed rate. And ABC means feed rate and speed. ABC means all the three. That's that. Okay. And one more. Now you just have to look at your ANOVA table. Now first guess. Temperature. Is temperature significant or not?
It is significant.
Because p value 0 is coming. 0 means less than 0.05. Another best way you can do is stat DOE factorial response optimizer. Now, what do you want to achieve with the MFI? Do you want to maximize, minimize, or any assign a certain target? We'll set a target, right? When I choose, set a target, then I have to actually mention the target. What is the targeted MFI you want? Let's say the targeted MFI is 2.8. Now the combination that can produce closer to 2.8, Minitab will show. Let's see. What is the closest value possible?
3.1.
3.1. 2.8 is not possible, but 3.1 is possible. So this is the advantage with dealing with the measured data. So this example is about DOE with three-level interaction. See, three-level interaction, you can straight away better come to response optimizer. Why? Because imagining, three dimensions and all, it's difficult for a human brain. So you have to make use of the response optimizer. Okay. So hope it is clear. Okay. If there are any questions, please ask. Otherwise, we can just take, a short, short and quick 2 minutes break. And then I want to switch to another topic, chi-square test. Okay. So, any questions? No questions? DOE or anybody would like to try using Minitab? I have seen somebody raising hand, in between. Who was that? You can ask the question now if you want.
Yeah, it was me, sir. Actually, for that speed, little bit speed, the level that we put was 3, but actually it was 2 in the table.
Which one? Which one? Level?
For L2,
Wait, wait,
for
wait.
the factor X2,
Wait, wait, okay. Okay. About this MFI problem?
yes, sir.
Yes, sir.
Yeah, correct. Two only, correct. But did I speak about level of the temperature is too?
I think it's a typo. Yes. If you scroll up a bit, it is L2 equal to 3. That is
Oh,
just
right.
a typo. We are talking about
Oh,
2
sorry.
and
Typo only. Right. Typo. It's two only. Two. All are two. One Minitab will automatically write everything for you. See here. It writes everything automatically for you. Now all that you want to know is the effect you have to study, and then the p value you need to look at. And after the p value, and if you look at this adjusted mean sum of square, based on this value, you can understand the influence. Now, which one has got a higher adjusted mean sum of square? 1.18. What is
temperature.
1.18? That means temperature. Temperature has maximum effect. Temperature has maximum effect on MFI. So in this way, this information will be helpful. Hope you all now understand, the DOE. Maybe we'll take a short, yes, quick break, and then we'll switch to chi-square test. Okay,
Okay.
2 to 3 minutes break. Resume the recording. Share the screen. Complete screen. Please confirm if you can see my screen.
Yes, sir. Could see your screen.
Yeah. So the attribute data in quality improvement, proportion test and chi-square test. So again, just a recap, understanding the data type. There is variable data, there is attribute data. Variable data means length, weight, temperature. Attribute data means defective, non-defective. Normally, now it's a categorization or count. Okay. The pass fail is an attribute data. Yes, no is an attribute data. Complaint versus no complaint is an attribute data. Defective versus no defective is an attribute data. So in for attribute data, we perform a hypothesis test known as proportion test. First of all, proportion means the number observed divided by total number. Number observed by total number. Suppose you produce 200 parts or you inspect 200 numbers. Out of the 200 numbers, you see 10 defects. That means the proportion defect is 10 by 200, which is 5%. Hope all of you understand now what is proportion. Purpose of the proportion test is you want to compare machines, whether the rejection is high in any particular machine, whether the rejection is very high or the complaint is very high in any particular shift. And whenever you want to validate the improvement, after the improvement, the rejection is reduced. And in all these scenarios, you can certainly go for proportion test. Yeah. When it comes to proportion, there is one proportion test and there is two proportion test. One proportion test means the observed proportion is compared against the reference proportion. Say, for example, in my company, for all critical processes, the permissible rejection is 2%. The permissible rejection is reference, but observed rejection is 5%. Now I want to validate that the rejection rate has significantly increased. Rejection rate significantly increased means the rejection of 5% is significantly higher than the normal 2%. So this, whenever you are comparing your proportion with a reference proportion, the test is known as one proportion test. When you compare the proportion of two groups, Let's say rejection in machine 1 versus rejection in machine 2, or productivity of your department with other department. Before rejection, after rejection, shift A rejection, shift B rejection. These are examples of two proportion test. When the number of group is increased to more than 2, then we need to go for chi-square test. That also we'll see. Now, it is a case of hypothesis test only. In proportion test, the null hypothesis is always the difference between there is the difference between the there is no difference between the proportion. If there are two proportions available, null hypothesis will always say there is no difference. Alternate hypothesis will say there is a difference. And as usual, we check the p-value. If the p-value goes below 0.05, we reject the null. If we reject the null, then alternate will qualify. Alternate qualify means there is a difference. So which is better, which is bad, you can conclude. Now, case study, two proportion test, machine 1 versus machine 2. Now you see you have two machine. One machine is producing 8 defects out of 200 parts. Another machine is producing 18 defects out of 200. Now you wanted to check whether the rejection is high in machine 2 compared to machine 1. This is the statement, or this is the fact you want to validate. So null hypothesis, there is no difference in the rejection. So P1 equal to P2. Can you see here? P1 equal to P2. But alternate hypothesis, P1 and P1 is not equal to P2. Now what you need to do is, there are some calculation involved. I don't want you to struggle with the calculation. And Minitab will do all of these things for you, but I will explain here. There is something called pooled proportion. Right? There is something called pooled proportion. Pooled proportion formula is total defects divided by total parts. Total defect is how many? 26. Total part is how many? 400. So 26 by 400 is 0.065. So we defined the hypothesis, we calculated the sample proportion, then we calculated the pooled proportion. Now we move on to the next step. Here we calculate standard error. The formula is the pooled proportion is P. N1 is number of sample in the first group. N2 is number of sample in the second group. When we do this, we get the standard error, which is 0.02. Now what we do is we calculate Z score. Z score is P1 minus P2 divided by standard error, which is minus 2.03. This minus 2.03 is converted into P value. Now what is the P value? 0.04. Now please tell me 0.04, is it less than 0.05? Yes.
Yes.
0.04 is less than 0.05. So you reject the null. If you reject the null, what does it mean? There is a difference. There is a difference. Now let's see how can we do the same exercise, in Minitab. I'll just share my Minitab screen. Yeah. Hope you are seeing my Minitab screen, right?
Yes, sir.
There
Good able to see your screen.
Total produced and the defects observed. Now you please tell me machine 1, how many unit produced? 200. How many defects you got? 8. And machine 2, how many units you produced? 200. How many defects you got? 80.
16,
Now
80.
with this, would you like to conclude that machine 2 produced more defective than machine 1? The numbers looks very obvious, but still we want to validate with the help of the available data. So this is a case. Here the null is P1 equal to P2. What is alternate?
P1 is not equal to P2.
Very good. Now go to stat. Go to basic stat. There is two proportion test. Click that. Now both samples are in one column. In our case, only summary is available. What is sample 1? Sample 1 is machine 1. 8 out of 200. Sample 2 is machine 2. That is 18 out of 200. Option. 95% confidence level. Null hypothesis, 0 difference. Alternate hypothesis, not equal to. And I want to use the pooled proportion method. Use the pooled estimate of the proportion. Okay. One more. Okay. The job is done. Look at the p-value. Tell me how much is the p-value?
Less than 0.05.
0.05, less than 0.05. So reject the null, which means the proportion of defects are different across two machines. Right? This is a case of two proportion test. I'm again going to the PPT. You are now seeing my PPT. Okay. Now you look at this slide. Now what do you understand? The same problem. Machine 1, machine 2, 8 out of 200 rejected and 18 out of 200 rejected. Now there is 4% rejection in the machine 1. There is 9% rejection in the machine 2. And 5% difference in the rejection rate is a significant difference. So we can't say both machines, produce same, defect levels. So this is the Minitab route I followed. Basic stat, two proportion, and then summary is entered. I got the result. This is the output we got from Minitab. Some kind of visual. Yeah. Let's assume another. Now, please look at my screen and you have to tell me. There is a call center in the daytime or the day shift. Out of 500 calls, 20 complaints were received. And in the same call center during the night shift, out of 400 calls, 36 complaints are received. Now you are the call center manager. Do you want to conclude that the shift has an effect on the number of complaints? Or complaint rate is it
Yes.
dependent on the shift? Which means if
It
you
is
run more night shift, then there'll be more complaints. So as a responsible call center manager, you might probably avoid the night shift and operate only the day shift. So what kind of test you should be doing now for this case? For the hypothesis test you should do?
in proportion test. Uh, two
Correct. Two
two
proportion test.
calls and two complaints.
Two proportion test. Similar thing. I want you to just put it in Minitab, look at the p-value and decide. Now, we are going for the chi-square test. When should we go for a chi-square test? Whenever you have more than two categories of data. Like in the machine example, there is machine 1 and 2. In the call center, there is general shift and night shift. Whenever you have third category also, for example, machine 1, machine 2, and machine 3, day shift, night shift, and general shift. Whenever your categorization is more than two, then you should go for chi-square test. Now imagine there are three machines: machine A, machine B, machine C. 200 parts produced using each machine. The defects expected are equal across the machine. Why? Because all of them are same machines, so the expectation is equal. And in chi-square test, the formula for chi-square is the difference between observed value and the expected value is squared, and then that is divided by the expected value. We'll see that in a live case. Yeah. What is the null hypothesis and alternate hypothesis in the case of a hypothesis test or in the case of a chi-square test? The null hypothesis is the variables are independent. What is variables are independent? The number of defects and machine has no relationship, no dependence. Or the customer complaint and the shift timing has no relationship or independent, right? And so chi-square test is also called as test of association. Now, alternate hypothesis, machine influences defect occurrence. Look here, there are three machines now: machine A, machine B, machine C. Machine A produced number is available here. Oh, good parts 180, bad parts 20. And 170 good part. That means again the part produced is 300 only. Good is here, bad is also here. Now you have to no, you have to come to a conclusion now. Whether all the three machines are considered equally good or they are different. What do you think? Mathematically, there is a difference. Now, statistically, whether a difference exists or not, right? Whether the defects has any relationship with the machines or not. This is definitely a case of a chi-square test. We can do it. See here. This is how you can actually know. This is how you can actually do the chi-square test in Minitab. This is the route available. Now the table, what you are seeing here, no, this table, this is known as contingency table. This table is known as contingency table. It's here. You see contingency table. Once you prepare the contingency table, and if you are able to enter the contingency table, then Minitab will do the chi-square test for you and then throw the p-value. So here in the previous case study, what is the thing we are studying? We are studying whether the defects has any relationship with the machine. How many machines are available? Three machines. How many machines are available? Three machines. And the defect rate, here the proportion is 20 out of 200. Here the proportion is 30 out of 200. Here the proportion is 10 out of. So whether any relationship exists or not. And this is the table. Now going to another example. Morning shift, afternoon shift, night shift. Number of scratches produced in the morning shift 50, afternoon shift 40, night shift 30. So the total number of scratches is 120. Same way, dent, say, and then the total. Now we need to find out whether the scratch or dent are dependent on the shift or not. Whether the scratch or defects or dents are dependent on the shift or not. Here we need to first calculate something known as expected value. The expected value, look at the formula, row total into column total divided by grand total. For example, for the first number, what is the row total? 80. Multiplied by column total. Column total is 120. 80 into 120 divided by grand total. Grand total is 180. Can one of you parallelly check? 80 multiplied by 120 divided by 180. How much it is? This is known as expected value. Expected score. Are you getting this? 53.33.
Yes, sir. It's 53.33.
Same manner, you have to replace every cell with the expected value. For 30, the row total will be 80, column total will be 60, grand total will be 180. Then for this thing, afternoon, for the 40, the row total will be 60, column total will be 120, grand total will be 180. Now, one of you please tell me how should I calculate the expected value for this thing, the dent of 20? What is the expected value for this 20? It is written as 20 only.
Total is 60
60
into 60
divided by.
divided by 180.
Okay. Now please do it. Even without
60
using pen and paper, you can do it. 60 into 60 divided by 180. How much?
3600 by 180. 20.
This is 20. Correct. You are getting 20. You see? Similarly, for this thing, what is the row total for 30? 40.
40.
What is column total? 120. What is the grand total? 180. So that will give
4800 by
26.67.
180.
Similarly, for the last number 10, the row total is 40, column total is 60, grand total is 180, 13.33. Now you understand the expected value for all the six count. Yes or no, all of you? Now we are going to calculate the chi-square. You see here, observed value 50 means expected value is 53.33. Observed value 30 means expected value 26.67. This is what we calculated in the previous slide. For 50, what is the expected value? 53. For 30, it is 26. For 40, this is 40. Now I'm just tabulating this.
So here the expected value is a calculated value and not the target value.
Yes. Expected value is calculated and this observed value. Now we calculate the chi-square. The formula is observed value minus expected value, and the difference must be squared and divided by the expected value. Do you understand? O minus E, the whole square, divided by E. So when I do that, I get different chi-square. When I sum up all these chi-square, that's the total chi-square. You see, chi-square is 1.88. Once the chi-square is 1.88, and there is something known as degrees of freedom. Now tell me, degrees of freedom, how many rows are there here? How many shifts are there? 3 shifts.
3.
So 3 minus 1, 2 is degree of freedom. Now type of defects, how many defects are there? 2.
2.
2 minus 1, 1. So the degree of freedom, there are 2 degree of freedom. One is 3 minus 1, another one is 2 minus 1, and hence the degree of freedom is 2. For a degree of freedom of 2 and chi-square value of 1.88 and at a 5% level of significance, the tabulated chi-square value is 5.99. But what is very important is this tabulated value can be converted into what? P value. Yeah. So you get 1.88 and 2. This is converted into a P value, which is 0.39. Now tell me, P value 0.39, is it more than 5% or more than 0.05 or less than 0.05?
It's more than 0.05.
More than 0.05. So fail to reject null. Fail to reject null means the scratch and the dents are not associated with the shift. Are not associated with the shift as per the data available. These are self-explanatory. You can use in this manner. Okay. So now we'll do, okay, anyway, I'll take some questions and then I'll show you how to use Minitab and do it. Now tell me, in quality analysis, which of the following is an example of attribute data?
Number of defective units in a batch.
Perfect. Yeah, proportion in quality control is defined as what? What do you mean by proportion?
And the ratio of defective
items to the
items to
total
total
items in a
items
sample.
in a sample.
Very good. Third one. The one proportion test is used to
Compare a sample proportion against a target proportion.
very good. In a two proportion test, the null hypothesis always states that
P1 equal to P2.
very good. Okay. In the example, machine 2 has a defect rate of 8%, machine 1 has a defect rate of 3%, and the p value is 0.012. What is the conclusion at alpha equal to 0.05?
P value is less than 0.05.
Okay. So what?
So there is
Reject HO.
So reject HO, which means there is a significant difference in the
Difference
defect
in the
rate.
defect rate.
Yes, sir.
The chi-square test formula is
Number 3.
yeah,
Observed minus
O minus
expected
E the whole
Observed
square
minus
divided
squared
by
by
expected whole
X.
square by
expected.
expected.
E. That's no chi-square. In a chi-square test, the null hypothesis states that
Two variables are independent. Number 3.
null hypothesis are two
Yes,
variables.
independent.
That is one thing. Or how about the two? The observed frequencies are all equal. Let us check the answer. Question 8. Which test would you use to check if defect rate differ between supplier A, supplier B, and supplier C simultaneously?
S- Chi-square.
Chi-square test. Chi-square
Nice
test.
question.
Chi-square test.
Proportion and chi-square test are applied at which phase? Root cause analysis. If the number of complaint is related to branch location and complaint type, which test is most appropriate? Where the complaint is
Chi
related to branch, yeah,
Chi-square
Absolutely.
or
test.
complaint is related to the complaint type, yeah.
Multiple locations and multiple complaint type.
Yes. So here are your answers. Which is the question we wanted to refer the answer?
Question 7. The two variables are independent.
Oh, you're right. Two variables are independent, correct. Okay, so now let's do one quick case study using Minitab.
So do you also share this presentation? I don't think it is shared
Yeah,
yet.
okay, I'll share. I'll share that. All right. So I have taken Minitab. You see here I've taken Minitab. Now machine 3 also let us add, no? 200. And here I say 22. Now the question is whether machine type and defects has any association or not. The null hypothesis, there is no association between defect type and machine type. Now this is definitely a chi-square test. Stat table chi-square cross tabulation and chi-square. Click that. Summary of this. Summary. Now these are the two rows. And the heading is machine. Chi-square test. Enable chi-square test. Give OK. Now you see 208.
See, the p-value is 0.04, less than
Yeah, 0.035 less than yes. So
less
reject the null.
than
Reject the null means defect rate
there.
and machine type are associated. There is a relationship. Hmm. In our Excel sheet, there is an example. So, our Excel only. Is one problem. We are finishing this list of proportion. I will show one example. Like casting. Ah, yes, this one. You see, what's produced defective, sir? Include casting industry. Sorry, took more time. See here, you can even create a summary out of the observation, or you can feed the raw data as it is. Minitab will automatically create the contingency table. So I'm just copying everything. Control C. I go to Minitab. I just paste it here. See, you can also create a contingency table in this manner, like north, south, east, west, total how many applications they processed and how many defects they committed. So here the defect committed is made available. 0 means no defect, 1 means defect. So now to do a chi-square test, now what we are trying to do is whether the number of defects is associated with the region of the office. Stat, table, cross tabulation and chi-square. Okay. And then see here, you can give a summary table, sorry, two-way table, or you can give raw data. In our case, it is raw data. And raw data in the rows column. Yeah. And in order to use this, we have to do a small little bit of preparation. What we need to prepare is convert this 4 column into just 2 column. For that, I want you to go to stat, and then I want you to go to data and then stack the column. What are the columns you want to stack? North, south, east, west. All these 4 I want to stack, but I want the result in the same worksheet. Column of the current worksheet. Let me say the column of the current worksheet. Where I want is C level. And I want the subscript in C10. When I do that, you see, this is the nothing. This is region. This is now defect condition. Okay. Now we are ready with stat table, cross tabulation chi-square. Now Again, we do not have summary. We have to proceed with the raw data. Now in the row information, you can put the region. In the column information, you can put the defect condition. Now tick the chi-square, tick mark, give OK, on give OK. Now look at your p-value. P-value is how much?
More than 0.05.
0.6. It's more than
6.
0.05.
So defects or defect rate is not associated with region. This is the conclusion. If it is associated with the region, then the region is the root cause. If it is not associated, then region, it cannot be the root cause. So do you understand, all of you? Probably you have to just practice in the minute app so that the p-value can help you to decide. Any questions? Now imagine you have three trainers, trainer A, trainer B, trainer C, and participants are giving the rating. Trainer A, how is the teaching? Excellent. Trainer B, average. Trainer C, bad, something like that. Excellent, average, and good or something. So now we have to find out whether really the performance level of the trainer is, or the, what do you call, the training quality is same across all the trainer or different. In order to understand the training quality, participants feedback we are going to use. If participants have said excellent for all the trainers, then there is no difference there. If participants are giving excellent to only one particular trainer, and then average for other trainer, and then bad for other trainer, then there is an association between the training quality of the trainer. Yes or no? So whenever you are dealing with more than two category with the proportion data, you need to do a chi-square test. Okay. So this material I will share, right?
Yes, sir.
So I think you can take a short break here, and then you will be taken through the rest of the topics after the break.
Thank you, sir.
Okay. Yeah.
Break.
ഒന്നിട്ടുള്ള പറയുമ്പോൾ മുതലാളി വെച്ചിട്ട് പിന്നെ ചെസ്റ്റിൽ നിന്ന് കുറച്ച് എത്തിയിട്ടു പിന്നെ ആ ചെസ്റ്റിൽ വേണ്ട എനിക്ക് വളരെ വേണം തപ്പോൾ ഇന്നൊരു ആട്ടിന് കാലിട്ടു അങ്ങനെ അവർക്ക് കാല ഇഷ്ടമാണ് തൊഴിലാണെങ്കിൽ ഒരേ കാലുണ്ട് തുടക്കമിട്ടപ്പോൾ രണ്ട് ചെസ്റ്റ് കിട്ടു പിന്നെ ചെസ്റ്റ് വേണ്ടായിരുന്നു നീ എന്താ ആചാര വീടുകളായിട്ട് എന്താ എന്താ പറയുന്നത് എന്താ പറയും അവരല്ലേ എന്തെങ്കിലും നമ്മൾ ഈ സമയത്ത് ജസ്റ്റ് അവർ എന്താ സംസാരിക്കും നമ്മൾ ലിസൺ ചെയ്യാം പിന്നെ നമ്മൾ ഇത് പിന്നെ അവർ ചിലപ്പോൾ പറയും എനിക്ക് പറയും അത് പിന്നെ അവർ പറയും ഇപ്പോഴേ പറയാറില്ല.
അവിടെ ഇരിക്കാനുള്ള കേക്ക് എന്താ അവിടെ എന്തെങ്കിലും ചോദിക്കുന്നത് കേക്ക്
ഇല്ല നമ്മൾ ഒരു ആന്റിസിപ്പേറ്റ് ചെയ്യണം. പരിചയപ്പെടാൻ ഇങ്ങനെ ഒരു അവതാരം സംസാരിക്കില്ല. നമ്മള് ഈ ടോപ്പിക് വന്നാൽ അനുസരിച്ച് ഓക്കെ അവർ തമ്മിൽ സംസാരിച്ചു ഇല്ല ഇൻ കേസ് എന്തെങ്കിലും സംസാരിക്കില്ല സംസാരിച്ച് അല്ലെങ്കിൽ ഉടനെ എപ്പോഴും നടന്നുണ്ട് ചോദിക്കോ എങ്ങനെ അതിനകത്ത് ചില ക്വസ്റ്റ്യൻസ് പറയുകയോ ഇല്ലാതെ
ഇഷ്ടപ്പെട്ടവരാണെങ്കിൽ അപ്പൊ
അതെ അപ്പൊ അതിന് എന്താണ് അടുത്തത്
ഇഷ്ടപ്പെട്ടിട്ട് രണ്ട് സംസാരിച്ചതിന് ശേഷം ഉള്ള പ്രൊസീജിയേഴ്സിൽ പിന്നെ നോക്കാം എങ്ങനെയാ അങ്ങോട്ട്
പറയണം. നെഗറ്റീവായിട്ട് എപ്പോഴും നെഗറ്റീവായിട്ട് പറഞ്ഞു ഇതാക്കിയിട്ട് പറയാ. അതിന് മുമ്പ്
നമ്മ കോഫി കുടിക്കണ്ടോ കോഫി ഉണ്ടോ അതാ ബ്ലാക്ക് കോഫി പാലല്ലോ ബ്ലാക്ക് കോഫി അതിന്റെ ഇടയിൽ അയാളെ ചോദ്യങ്ങൾ തൈറോയിഡ് ഇല്ല
ചേച്ചിക്കറിയില്ലേ ചേച്ചിക്കറിയില്ലേ സംസാരിക്കുന്നത് ആ ചേച്ചി ജസ്റ്റ് ഇൻ കേസ് എന്തായാലും ചോദിച്ചു ജസ്റ്റ് ഒരു എക്സ്പീരിയൻസ് ഉണ്ടാവും. നിങ്ങൾ എന്താ പറഞ്ഞു ചോദിച്ചാൽ നമ്മൾ എന്താ പറയുന്നത്
जैसे आता है ले लोगोंना बात करता है ना आपण काय ऐकायचं या लोकांना
आणि जास्त नाही विचारतात कसं आहे तुझ्या गोष्टीच्या घरात आई बापचा आणि आपली नोटला पडतं म्हणजे परिचय diciamo avere chiama practice
आपण ले लोकांना विमान बोला ते लोकांना पसंत ज्यादा तर मला तर बघायची गरज नाही ना पसंत ज्यादा त्याने ना पसंत ज्यादा पण मग माझ्या काय नाही आहे कुठल्याही बघायचं ना आता
केलं खूप चालतं मागितल्या काय कसं तुझं पगार आणि आता तू परीक्षा पडला तू पुढचं काय नाही तू आधी चांगला पडायच्या काय बघायच्या ऑल इंडिया बेच
आगे शिकायचं तर आपल्याला पैसा भरायला होणार का
नाही करायच्या ते लोक all India beach ना आपल्याला अशी all India beach टेस्ट
त्याला पसंत झाला तर आपण बोलायचं काय आपण जायचं का ते घ्यायचं
बघायचं
पहिला ना
हा ते लोकांना नाही
नाही जे बोलत होतो त्याचा बाप यायचा बोलत होतो असं कसं त्याचा बाप मी बोलला पहिला तर मुलगाचा घरातून जातो बोलायला
लोकांना पण काय असणार
नाही त्याचा मुलगा पण इकडे आहे ना
हा
म्हणून येतो असणार त्याला पण काय यायचं बघायचं आणि मग तिकडे पण यायचं मला वाटतं इथे मॅप नाही द्यायचे मॅप देणार तर मग तिकडे येणार ना आणि ऐकायला सगळ्या मी काय बोलतो त्याला मला इकडे बोलवायचं पहिला आणि इकडून आपण पण यायचं आणि इकडून आपण घेऊन जायचं त्याला मॅप देणार ते शेअर करणार ना म्हणून इकडे येऊन कोणाला सगळं ऐकायला पण इकडे यायला सांगायचं मुलगाला पण कोणता चढवतो त्याच्या आणि आपण इकडे यायचं आणि इकडून मला पाहिजे तर तिकडे आम्ही म्हणतो
വേറെ പെട്ടെന്ന് നിങ്ങളുടെ എക്സ്പെക്ടേഷൻ പെട്ടെന്ന് ഇറങ്ങാൻ അതമാതിരി തോന്നി ചോദിച്ചാൽ
എക്സ്പെക്ടേഷൻ
ഇല്ല അന്ന് വന്നാൽ ഞാൻ എന്താ പറയേണ്ടത് ഇല്ല വേണ്ട അതാ
എവിടെയാണ് പഠിക്കാനും സപ്പോർട്ട്
ഇല്ല അതൊന്നും നമ്മൾ പറയില്ല ചേച്ചി പറഞ്ഞ മാതിരി ഇഷ്ടം അങ്ങനെ ഇഷ്ടമുള്ള കറിയുന്ന വാക്കില്ലാതെ അതാൻ പറയുന്നത്
അങ്ങനൊന്നുമില്ല അങ്ങനൊന്നുമില്ല എത്ര
Good afternoon, all of you.
Sir, afternoon.
Good afternoon, all of you.
ജോലി
Yes.
പോസിറ്റീവായിട്ട് പറയാം
കുട്ടിക്ക് പഠിച്ചിട്ടുണ്ടാവും കുട്ടിക്ക് ചോദിച്ചിട്ടുണ്ടാവും അതാണ് മെയിൻ എക്സ്പെക്ടേഷൻ
Somebody is speaking on the background. Mute yourself. Who is speaking on the background? Mute yourself, please.
ജോലി അത്രേ ഉള്ളൂ
വിദ്യാഭ്യാസം ജോലി ഇതാണ് എന്റെ മെയിൻ പ്രിഫറൻസ് കാര്യങ്ങൾ അത് പറഞ്ഞിരിക്കണല്ലേ
Dr. Siva, are you there? Dr. Siva?
നമ്മൾ ശരിയാണ് എനിക്ക് അവര് ജോലി ഏൽപ്പിച്ചില്ലാലോ
നമുക്ക് ജോലിയിലൊക്കെ വേണ്ടത് പകല് ജോലികളൊക്കെ കിട്ടുന്നതാണ്
അങ്ങനെ എന്നല്ല പറയട്ടെ സമാധാനമായിട്ട് പതുക്കെ ജോലിയായിട്ട് കല്യാണം എന്നുള്ള ഇത് പറഞ്ഞാൽ മതി
3 വർഷം വരെ 4
I think you need to mute everyone.
എന്ത് പറയുന്നത്
Ravi Kumar sir, you are made the host.
Okay, okay. Thank you. Okay, guys, welcome back. We are going to see the control charts for attribute data. So all of you are back. Let me start the recording. The recording is already on. Okay, guys, so what is the purpose of the control charts? Yes, guys, what is the purpose of control charts? We'll recall what you have learned earlier. What is the purpose of the control chart? Come on, guys, what happened?
To verify that our process is operating in a controlled manner.
Yes, to find out whether the process is in control or not. Okay, so you must be aware that the control chart is mainly used in the control phase. Why we are using it? Okay, because we want to be sure that the system, that the process is in control or not. We want to determine whether the process is in control or not, and we want to find out whether the solution which you have implemented in the improve phase has really performed or not. In order to identify that, we need to use a control chart. Okay, so it is mainly used in the control phase in the first step where we are implementing some control systems for keeping the root cause under control. Okay, so to monitor the stability and to demonstrate whether the solution which you have implemented has really worked or not. Okay, in order to find out that, you need to use a control chart, and also to determine the readiness for the improvement of the process, whether the process is ready for improvement, can be also identified through control charts. So already we know this, right? Common cause and special cause. Okay, so these are the types of data and the specific control charts which you have to use, okay, accordingly. So earlier we have seen this variable data control charts. That is when the subgroup size is 8 or more than 8. Okay, what type of chart will you use, guys? It is a
X bar is chart.
X bar R chart or X bar S chart.
S chart.
Okay. When the subgroup size is 8 or more than less than 8 or more than 8, you have to go for the average and range chart or average and standard deviation chart. So you have to be very clear what is the subgroup size. That is a sample size which you are collecting at a time. That is called the subgroup or the sample size. So based on the subgroup size, we are choosing the type of control charts to be used. Okay, suppose if the sample or the subgroup is just one batch, okay, then it is going to be an individual moving range chart. Okay, this is specifically for data when the data is continuous or when it is a measurable data. What do you mean by continuous data or measurable data, guys? Is what do you mean by that?
When we can able to measure any data with some metrics, it's a
Yes.
continuous data.
Yes, only if
Measurable
someone
data.
is available. If someone is available online, others are taking a rest, I believe. So others also can participate. Okay, yes, please. Good. Okay, so when the data is measured and collected, okay, like length, width, diameter, area, volume, calories, okay, time, temperatures, specific humidity, anything, weight, mass, okay, gravity, whatever it is. Whenever you are measuring any data using some measuring gauges and you are collecting that data, it comes under the continuous data or variable data. Okay, so whenever you have a data like that and you have the sample size accordingly 1 or less than 8 or greater than 8, you have to choose the any one of these three control charts. Okay, now let us move to the attribute data or countable database. So here you are going to uh, choose the chart, okay, based on two types of data, that is data for defects and defectives. Data for defects and defectives. For defects, okay, what is a defect, guys? What is a defect?
If there are
Types of defect, any damage,
damage,
scratch in one product, which is
Okay,
not, we need not scrap that total product. Product, if after repair, the product is usable.
so if there is a flaw or error or fault
Error.
or any unconformance, okay, inconformance, okay, or a variation or a fluctuation or a difference, then it is considered as a defect. This defect may not be crucial, but when the product is rejected, okay, unaccepted, okay, so it is scrapped, then we consider that as a defective. Okay, so you must be aware of the difference between defect and defectives. Okay, so when it comes to dealing with defects, see, for example, let me say, uh, you may be having a lot of rejections. Okay, you may be having a lot of rejections. That is called defectives in your process. So, suppose if you want to know why the defectives are happening, then you can choose a sample of 15 days and collect the type of defects which is occurring frequently, and you can plot in the control charts. Okay. Suppose if you want to know in which period the defectives are more, in which period the rejections are more, then you can go for a defectives chart. Okay, so you can choose a right type of chart depending upon your process need. Okay, so in defectives, In both these cases, you are going to deal with numbers only, not continuous data. Okay, it is just like numbers. Okay, whether how many defects or how many rejections. Okay, when the defect, okay, is varying, that is, for example, that so for example, if you are going to go for a control charts of defects, if the sample size is fixed every time, that is, if you are going to collect same number of samples every time you inspect. Guys, do you got me? That is, for example, let us say you are going to collect, you are going to audit a particular diagnostic laboratory.
இருக்கேன் ஹைட் கம்மியாயிட்டு
If you are going to collect samples, for example, let us take a diagnostic lab. Okay, let us say a doctor is going to audit the diagnostic lab every week. Every week he is diagnosing, okay, same 15 number of tests. For example, the lab is making 50 tests every time, and the doctor is choosing 10 number of tests every time for inspection, 10 number of test samples for auditing. Then it is called a fixed sample size. Okay, fixed sample size. Suppose, let us say he audits 10 this week. Next week, he audits 15. And after that, he audits 8. And next week, he audits 18. If the sample size which you collect and verify, if it varies every time, okay, the number of samples you choose for inspection, if it is same, similar, equal, then you go for C chart. If it varies, you go for U chart. Okay, this is regarding the defects. Okay, now what about defectives? Suppose if the number of samples you choose for inspection, okay, if the number of lots you choose for inspection, if it is a fixed one, if it is fixed numbers every time you inspect only same numbers. For example, every 1 hour you are going to check for rejections. You are a quality inspector. So every 1 hour you are going to check for inspection. Every time you check only 5 lots or 5 numbers. Then it is a fixed sample size. In that case, you have to go for non-proportional chart. That is the NP chart. Suppose you are inspecting different numbers every time. First hour, for example, 8 to 9, you are inspecting 10 numbers. 9 to 10, you are inspecting 12 numbers. 10 to 11, then you are inspecting 8 numbers. So if the number of samples you inspect, if it varies every time, it is called a P chart. Okay, so you have to use a P chart. So this is how you have to select the charts. Are you guys clear about how to choose the charts, everyone? Yes, no, guys, give me.
Yes, sir.
Yes, sir. Clear.
Okay. So based on the type of data and the number of samples and the type of samples which you collect, you have to decide the chart C, U, N, P, and P. Remember, for defects, it is only C and U, and for defective, it is N, P, and P only. Okay, so now let's move. So already have learned this X bar R chart. Now go to this P chart. P chart is for defectives. P chart is for, remember guys, P chart and NP chart is for defectives. That is when you are going to find out the percentage, when you are going to deal with the rejections in your process, not defects. When you are going to deal with your rejections, whether the rejections are in control or not. Earlier, you might have suggested your top management that after the implementation of the project, the rejections will be 2%, 3%, like that. You might have promised them a goal. Whether that goal has been achieved, you can check it out using this P chart. Okay, this is purely for dealing with defects, whether the particular inspected lot is defective or non-defective. Okay, yeah, the sample size can vary from different in different inspections. Every time you inspect, every time you select samples for inspection, you may have a different number. Okay, that is why it is called a P chart. Okay, so I believe it is better. All of you, could you open the mini tab, guys? Could you open the mini tab in your laptop? Please open the mini tab in the laptop. It's done. All of you give me yes or no. Have you opened the mini tab?
Time is I'm attending to mobile. Mail. I did my laptop.
Yes, open it quickly, guys. To share the screen, then I can show you the mini tab. I think now you are seeing the mini tab in my computer, right?
Yes, sir. Good to see.
Yes, sir.
Okay, so in the meantime, okay, let us see how. So for all these control charts, the basic things which we must know is a center line is calculated and the upper and lower control limits are also calculated. So earlier you might have learned this in the X bar R chart, right? So okay, I think Santosh, you cannot open it through mobile, so you need only laptop. You can use your mobile for connection, and for mini tab you can use a separate laptop if possible. That only could help you. Okay, no problem. So you can just follow me and you can listen and observe closely, so that you will remember and you can use it later onwards. Nothing to worry. Okay, guys, let us see. So this is how you are going to. This is how it is going to work on the background. The center line, okay, the average line, the mean line. This is how it is calculated, the upper control limit and the lower control limit. So based on this only, the P chart is generated. Okay, now let us go to an example. I think all of you might have, okay, all of you might have used this example, right? See, you have received this file, right? Sigma level calculator. In that you have a file called sheet called P and NP chart. We got that sheet, guys. P and NP chart. Please open the Sigma level calculator. Okay, Excel file which is shared to you by Dr. GSK. In that you have a sheet named P and NP chart data. Got it? Yes, guys, give me a response so that I could
Yes,
know
yes,
that.
got it. Yes.
Okay, now I believe all of you have opened it. So if you don't have Minitab installed in your laptop, or if you don't have a laptop right now, you just follow me, observe me, and listen to me. And remember, okay, now what we are going to do is we are going to copy this thing. Okay, that is the first two columns. That is parts produced and rejected. Okay, so here you can see the parts produced and rejected. The parts produced is considered as the number of samples inspected, and it seems to vary every time. Okay, let us place this and paste it on the C1 and C2 column. So parts produced, first day 98, rejections 20. Second day, it is considered as inspected, 104, 18, like this. All of you have done this, copied and pasted it. Has all of you done this? Yes, no?
Yes, sir.
Okay, now we will go to the statistics, which is on the top, statistics, control charts. Now you have to go for the third link, attribute charts. In the attribute charts, you have P chart, not P chart diagnostic. Just click on P chart. Guys, do you got it? It's P chart.
Yes, sir.
Click on that. You may got a table like this. Got it?
Yes, sir.
Now click on this side and click on variables is a parts produced. Variables is a rejections. And subgroup size is the parts produced. Have we done this? Guys, have you done this? Give me a yes or no. You have to give me a response then and there. Have you done this?
Yes.
Okay, now click on OK. So do you got a graph like this? Yes. Anybody want me to repeat the process of the chart?
No, sir, it's clear.
Is all of you guys got it?
Sir, one doubt, sir.
Yeah.
I am working laptop. I can open a mini tab, but parallelly, how to open that Sigma calculator? I am finding difficult because your screen is also there, and background mini tab I have opened. That Sigma calculator, how to open? I'm that basic.
Sigma calculator is an Excel sheet, right? It is an Excel sheet provided by
Yeah.
GSK, right?
Yeah, because
Yes, you can
that link is in the mobile. But how to bring
Which
it
link
in
is
the
in mobile?
laptop?
Which
That
link is in mobile?
the classroom, some folder.
See, actually, you don't have to share it in my laptop. See, you are having,
How to
you are
get the
attending
data?
the Zoom. You are attending
Yeah.
the Zoom in the mobile.
Yeah, correct. Zoom in the laptop.
Okay, no problem. Just minimize the Zoom. In the
Okay.
meantime, you can open the mini tab.
Mini tab
You
opened,
can,
already opened.
okay, then open the Excel sheet also. You could see
Just,
the Excel sheet like this, right?
yeah, that sheet.
Excel sheet, which is named as Sigma level calculator.
Yeah, where to get that?
You can open that and copy paste the first example from P
Yeah,
and
where
P
to get
chart.
that Excel sheet?
Actually, it was given to you by Dr. GSK shared the group, I believe. Others, how do you got it, guys?
Maybe I'm getting. I need to check. Maybe in the classroom, some folder it may be available in the mobile. But how to?
It's available in the WhatsApp chat, Murali.
WhatsApp. How to convert it to that laptop? That is one concern.
You
So
can
you
use
have it in the WhatsApp
web.
chat. You send you from the WhatsApp. You send it to the laptop
Mail
through a
something. That
mail.
link
Yeah.
we need to send to mail to laptop.
Yes,
From
you
there you
send to
have
the
to
mail.
open.
You have to
Mail.
download it and then you have to open it.
Yeah. Okay, sir. I'll
Or
do
else you
it
can
parallelly.
also
You can continue, sir.
use WhatsApp web also. That also works.
Or if you have installed the WhatsApp in the laptop,
It's
you can
not there.
directly
Correct. It is
download it.
not there. Okay, I will.
Yeah.
I will do it later, sir. I got the point. I understood. Now you can continue, sir.
Okay, in the or I can share. So you are also having your. Okay, what I will do is, if you want, I can share it in the
Chat box.
Yes, chat box. You want me to share in the chat box? I can chat.
Yeah, that will be helpful,
Okay,
sir.
listen. Okay,
Because
let
all
me
people
go.
are having in the mobile.
Oh.
So that.
Okay, now it is in the
cancel.
chat box.
Okay,
You can
sir.
see. You can check.
Yeah.
There is an Excel file called CNU, but there is a NP also. NP data is also there. Please check it out, guys. Got it?
Yes, sir. It's opening. So need to download or to copy?
Yes, you need to download and you have to open it.
Okay. Yeah, C and U.
Yeah, open it and you have
correct.
two
It is
views.
opening. So which file? That part produced and rejected. That you have to copy, sir.
P and P. P and NP is there, right?
P and NP.
There is a sheet called P and NP.
C and U. That is
file.
C and U is the
That
file
is a
name.
Yes, if you open it, you could see two sheets.
P and NP. Correct. P and NP chart.
Yes, open.
That
you
open.
open that. Yeah. Then you on the left hand side you could see parts produced, parts rejected.
Yeah, part
right?
produced and rejected.
Yes, copy the two columns and you can paste it.
Yeah, one minute.
And yes, paste it in the mini tab like this,
Yeah,
and you could generate the
okay. Yeah, one minute. That's copied.
chart.
And just I'm pasting in the mini tab.
Yes.
Yeah, copied, sir.
Then you have to go for statistics.
Yeah, one
Sorry,
minute.
copied it?
1 minute. Stat.
Then
Quality
click on
tools, sir.
statistics.
Hmm.
Yes, control charts, not quality rules, control
Control
charts.
charts.
Then there the fourth link, attribute charts.
Attribute charts.
Then
P chart
the second
diagnostic.
one, P chart. Yes, P chart.
Second one.
Yes, second one.
First is P chart diagnostics. Second is P.
Yes, choose a P. Then you could see the parts which are produced and parts rejected in the
Okay, so both you
vertical
need to
column.
select the part produced. You
No,
need
no.
to select.
Yes, click on the variable box, then click on the parts produced. Click on the variables box, which is a horizontal one, then click on the parts produced. Double
Yeah,
click on
it is.
that. Oh, sorry,
It is
sorry.
transferred.
Sorry. No, no, no. Just remove that. In the variables, you have to click rejections.
Yeah, okay, sorry.
Variables, you have to click on rejections. In the subgroup size, you have to click on parts produced.
Variables, rejected size. And subgroup size?
Parts produced. Column C1.
Parts produced. Yeah.
Now click on OK.
Yes, selected. Then scale.
Click on OK. Click on OK.
Okay. Click on OK. Okay. Yes, sir. Thank you, sir. Thank you so much. You got the
you
chart.
got a chart
Same
like
chart.
this?
Same chart. Yeah, correct.
Does anybody else have a doubt, guys? If you have a doubt, no problem. You just ask me. I will guide you.
Yeah, it's very helpful.
Okay. So remember, this is proportionate chart of rejections. That is, when you are going to consolidate or find out how many rejections or when the rejections have exceeded the percentage you have fixed, or when the rejections are more in a particular month, you want to find out on which day the rejections are more or on which day the rejections have exceeded the target, then you can go for this P chart. So when you have to use a P chart, guys, the first and foremost condition is the sample size will be varying every time. Here you can see that is why the boundary of the upper and lower control limit line is varying continuously. This indicates this kind of upper and lower control limit indicates this is a variable sample size data. That is the number of samples you select for inspection varies every time. Okay, that is what we mean by this. Okay, now in this you could see some of the points are so close to the center line and some of the points are above the upper control limit. So what we must do, we must immediately inquire or investigate the reason for the particular point going above the upper control limit line, and you have to investigate every possible process error from the data collection process, measurement system, and everything should be thoroughly verified and checked out. And if all these things are correct and if you still could not find out, you have to go for a Six Sigma project. Okay. Simply, otherwise, if you are able to find out the reason, the operator might have entered a wrong data or there is something not fishy, anything if it is not fishy and you are able to find out the reason for the point going above the upper control limit or the number of rejections going above the upper control limit on a particular day, that is well and good. You can solve it and document it and you can shut it down. Okay. So apart from this, you can see more number of points are close to the control limit. So you also have to investigate these portions. See what you are seeing on the screen, guys, especially from the 11th data, most of the points are close to the center line. This indicates something fishy. So it is an important thing that you must go and investigate and check the data collection process and the operator and all the measurement system connected with the particular uh, sampling. Okay, so then if everything is clear, then there is no need to worry about the chart.
Sir, sorry to interrupt.
Yeah, sorry, just go ahead.
When the many points are nearby the center line, why we need to investigate actually?
Okay, that's a very good question. Okay, I like to add more on this.
You need to check for
many
the
points are close to the center line. Just come.
rules.
Okay, wait. I will get more data for you.
Because in normal control chart, the closer to the mean, it is advisable. So that's the reason, same doubt.
And also we need to check for trend, right, sir? Okay, I think we have some eight rules or eight
abnormalities.
Checkpoints, abnormalities that we need to check.
Yes, that's what I'm doing. You are seeing another slide.
I think even the previous slide, it was available, I think.
Previous slide. No. It was not so. Actually, this is. Well, I have this test. Yeah, here it is. So here you can see. Here there's a variation. Okay, let us this one. Here, when the points are either too close or too very near to the center line, there is a possibility of abnormality. The reason is the operator might have entered a fabricated data or a predicted data from without collecting the data properly. Guys, do you get it? So when the data is very close to the center line, there is a chance of any fabricated data being entered, or the data collected without going to this particular site at all, and the inspection process not carried out properly. And suppose they might not carried out the inspection at all, but at the end of the month they might have entered, or they might have manipulated some data and entered it. So these kind of possibilities are there. Okay, so you don't have to suspect it 100%, but you need to be suspicious about it, and you have to just cross check whether the data collection system is correct, whether the data is collected foolproof, and whether the data is reliable. That is what we want to assure. If those things are correct, then you can ensure that the process chart, okay, control chart is absolutely fine and good. It is just a suspiciousness. Okay, that's it. Got it, Suresh?
Yes, sir. Thank you, sir. Understood.
Okay. Similarly, we have some other similar abnormalities also. Here you can see the points are continuously declining, right? See, the normal thing is the data points are inside the limits. So everybody will be satisfied. Everybody are quite cool about it. Yes, guys, come on, everything is good and fine. No, but obviously there must be an instinct which should inform you to check, which is insisting you to check whether the data collected is proper, whether it is credible data, whether it is a reliable data. First, you have to ensure that. How you check the process of data collection? That is, check whether the MSA was carried out before collecting data. When was the MSA carried out? When was the MSA done? Whether the whether the technician who is collecting data, is he trained properly, and whether he is following the correct operational definition, whether he is following the correct format, units, frequency, everything must be verified. Then, if all these things are correct and if the chart is like this, then you can accept it. Otherwise, if anything is wrong in any of the inquiries, you have to dismantle the entire data collection procedure, and you have to do the MSA once again, okay, and select a proper data collection trainer, technician, then collect the data, then plot the control charts. Okay, guys, got it? Are we clear,
Yes, sir.
guys?
Thank you.
Yes, sir.
Yes, sir. Clear. Thank you.
Okay, then one more abnormality we will see. See here, it's too close to the average. Okay, then this also, what does it indicate? See, it looks very nice on the chart, guys. If it is like this, then obviously it shows your process is excellent. But you have to find out whether this is a real data, whether this data which was plotted was a correct one, not a manipulated or fabricated one by the operator. So verify that, verify everything, not only the data collection procedure, the chart, the unit, the frequency of data collection. Okay, suppose, for example, there are 3 shifts happening in a process, but your technician is collecting data in only one shift, okay, in the morning, okay, for all the 30 days, then obviously there is some flaw, right? In the second and third shift, there was no data collection, so the sampling procedure was wrong. So that kind of the inspections could reveal that kind of, okay, loopholes or flaws that is present in the data collection procedure. So that is where you have to be very careful. So we want you to be suspicious. We don't want you to, okay, not believe it. We don't want you to reject it, but you have to be suspicious that there is a possibility of some kind of manipulation, interpretation, negative interpretation, or kind of fabrication of data and plotted. So we need to predict that. Okay. So this kind of abnormalities may present, but it doesn't look like an abnormality. Okay, that is the beauty. Here you can see data are far away from the center line. Okay, data are far away from the center line. So that is also a possibility. So how measurement system issues. So the measurement instruments may have poor resolutions or round off values. See, let us say, for example, vernier caliper measuring can only to the nearest 1 mm. When finer measurements are needed, they will round everything to 1 mm. For example, if somebody is using vernier caliper, okay, the least he can measure is 1 mm. Okay, let us say 1 mm. So whatever readings he got, he will round it to 1 mm. So he had to go for a finer digital vernier caliper instead of a regular vernier caliper. So these kind of errors can be identified if only you inspect the process, you inspect the measurement data collection process based on this kind of charts. Okay. So there is a possibility of tampering of the data. Okay, the operators adjust the process too frequently to keep it in the target. Okay, they actually, if this will artificially reduce the variations around the center line. Okay, so that is why the data is too close or too far away from the center line. So it is mainly the data collectors are trying to tamper. Okay, the operators trying to bring the process, are trying to show that the process is in control, are trying to show that the process is close to the target. Okay, so this is also an abnormality, and another abnormality is, so here you can see there is some kind of pattern, right? A sine wave pattern. So in natural process, no pattern is not possible. Okay, it doesn't occur. A pattern doesn't occur. So you have to ensure that if there is a pattern, you go and verify this and find out whether the operators are collected it properly, no manipulation, okay, no data manipulation or tampering. You check it out. Okay, so all these abnormalities, even though these control charts are looking well and good in paper, it is your responsibility to be suspicious about the particular data and verify its credibility, verify its reliability. So if the data is reliable and if the chart really occurs like this, then obviously you can leave it. Okay, no problem. Okay, so this is how you generate the P chart, guys. Now you go for the, so all of you are clear with the P chart, right? All of us
Yes,
are
sir.
clear with the P chart. Yes, now we
Yes.
go
Yes,
for
sir.
the next chart. What is the
Yes,
next
sir.
chart? Next chart is the
NP chart.
yes, NP chart. Yes, NP chart, right? NP chart. So this NP chart is going to deal with the defectives, rejections, when the samples are same, fixed. Okay. So here is the NP chart. So, okay, NP chart. So here for NP chart also you have a formula like this. So for calculating the center line and for calculating the upper and lower control limit, you have a formula. So okay, this is, they do it manually. Okay. So if you, but we are going to work out using the many data. So this is the data. A manufacturing company, okay, company which manufactures smartphones want to assess whether its process is in control or not. Okay, so company wants to know whether the process is in control or not. That is whether the variations is within the limit or not. Okay, so samples of the mobile phones were taken every hour for 3 shifts. Okay, so for every hour for 3 shifts they are collecting the samples, and the number of samples collected is fixed. So when the number of samples collected for inspection, if it is fixed, then you have to go for a NP chart, non-proportionate chart. So this is a sample size. So all of you can check the Excel sheet or this sheet which I shared with you. Okay. The last example, parts produced and parts rejected, right? You can copy that. parts produced and okay, now paste this in the menu tab in column C4 and C5. Guys, have you done that?
Yes, sir, done.
Have you done this? Yes. Now let us go to the same statistics, control charts, attribute charts, pick an NP chart.
On control chart, attribute chart,
and in the fourth one you have the NP chart.
NP chart. And here variables.
In the variables is a parts rejected C5. And in the subgroup size, it is a parts produced C4.
Subgroup size C4. Okay, then
now click on OK.
Okay.
Click on OK.
Yeah, same thing. Correct, sir. Getting.
Yes, all of you got it. Got a graph like this.
Yes, sir.
Yes.
I think 12 point UCL is 12.79, some variation, minor variation.
Okay.
And
but here you can see there is a
5.7.
Yes. And LCL is 0. But here you can see there is a continuous inclination. There is a continuous declination. Sorry, continuous inclination. Okay, from point. Yes. So you have to just cross check these data, whether there is any tampering or manipulation, fabrication of data. Just cross checking, guys. This is nothing. Just it is not about worrying. It is just about cross checking to make sure everything is normal, everything is working right. Okay. Yes, our objective is to ensure that the process is within the control limits. Okay. As all of you are done here, all of you have done it. Yes.
Yes, sir.
Is anybody having doubts, questions? Okay.
No, sir. Not from me.
Okay. Okay, now let us move to the next one. We are going for the next one. That is the defects. So far, we have dealt with defectives. The defectives are dealing with, for defectives, you have two types of chart. That is the C chart, NP chart and P chart. Next, we are going to do the defects.
Excuse me, sir. One doubt that P chart we are using whenever sample size vary every time. And NP chart?
The sample size is fixed. That is, you are going to inspect same number of samples every day.
Okay.
Okay, that is the last one, which we number the smartphone inspection. Samples was always 300, right?
Okay, so sample size same.
Sample size will be same.
Okay.
That is a condition for NP chart.
Okay.
Okay. So now let us go for the defects. The defects, you have two types of charts, C and U. C is for fixed and U is for variable. When the samples you are inspecting is going to change, it's going to vary, it's going to not remain the same every time, you go for U chart. When you are going to inspect same number of samples every time, okay, for defects, okay, earlier you are going to inspect for rejections. Either you are going to reject or going to accept. That is how your report is going to be. In this case, you are going to find out the defects, type of defects. Okay, type of defects are defects present in a particular product or process or service or system. So obviously, in this case, you have to use a U or C chart. Only U or C. Okay. So U is for a variable sample. Okay, when the sample size is variable, you have to use the U charts. Okay. So for U chart is also, you have a formulas like this. That is a central line, that is the average line you have to calculate. Then you have to calculate the upper and lower control limits. And then you have to plot the charts. Okay. Let us take this example. See, for here, there is an example that is in a particular stenographer company. Okay, a stenographer is making a lot of pages every day. So they sample 25 pages. Okay. and counted the number of typographical errors for each sample. So if not 25 pages, they sampled 25 samples. They collected 25 samples. Okay, and the 25 samples every day they checked different number of pages. The number of pages inspected were different every time. Okay, so first time 30 pages were inspected, second 24. Like this, the sample is varying continuously. So what kind of chart you have to use, guys? When the sample is varying, you have to use VU, right? When the sample is varying and if you have to check the defects, you have to use a U chart. Okay, now let us go to the go to the sigma level calculator or the chart which I have shared you. Okay, you have this, right? You have the U and C chart. In that you have the pages and the typographical error. Guys, do you have this page which I am showing you in the screen? Copy this. Copy this and paste it in column C7 and C8. So it will be easy for us to identify while we are generating the chart. Click on statistics, click on control charts, click on attribute charts. Now click on U. Guys, got it? Guys, all of you are there with me? Yes, no?
Yes, sir.
Okay,
Yes, sir.
click
Yes.
on U.
Yes, sir.
Now the variable is the typography error, column C8 typos. And the subgroup size is the number of pages. Have you done up to this?
1 minute.
Okay.
Stat.
Go ahead and do it. And if you have any doubts, ask me.
So stat control chart.
Same thing. Control charts, attribute charts. In
Attribute
that you
chart.
go.
U
In that
U
go
chart.
for U. Yes,
U
click
not
on U
U
chart.
chart. Yeah.
Now under the variables, you have to choose C8 typos, typographical error.
Okay.
For the subgroup, you have to choose for the pages.
Okay. Okay.
Now click on OK. Click on OK. You got a chart like this? If you have chosen the wrong data, you might not get it. Please ensure that you are pasting the number of pages and the typographical error on column C7 and C8. Column C7 and C8. Then only it is easy for you to identify and choose the correct data. You are the data. All of you have done this. Done it? Yes, no? Any questions, doubts? Anybody want me to repeat it?
Yeah, I got some different graphs.
Sir, can you do it again, sir? The statistics.
Okay.
Yeah, C7, C8 pages typo.
Okay, have you pasted up to this C7 and C8?
Yes, sir.
Yeah, C7, C8.
Yes.
Yeah, done, sir.
Okay, click on control charts, attribute charts.
Stat, control
U
chart.
U chart.
U chart. Okay.
Attribute chart.
Click on U chart.
Okay.
U chart. U chart is not U chart diagnostic. Plain U chart.
You have to choose U chart. Now diagnostic. Only U chart.
Only
now,
U chart.
On the variables, click on typos. In the subgroup size, click on pages.
Yeah, but it is coming. The C5 is coming 4
Yeah,
and the C4 is 300. I don't know.
That is no. Actually, that is the previous chart.
Okay. So that we need to cancel, sir.
Actually, are you able to see the screen which I am showing you?
Yeah, I am able to see, sir. That is C4, C5 is there.
I got it.
Actually, C7, C8 is there.
Yeah.
Click on in the variables. Click on C8 typos.
Yeah, but 1 minute. But here,
no, sir. For him, might be not C7, C8. For him, actually, it's a different. Because how he copied.
For me also, the title is C7-T and C8-T, and below that, pages typos are there.
Okay.
Correct. It is coming C4 and C5 is coming. C7 and C8 is not displaying.
Should we refresh? I don't know.
Where
The
did
chart.
you paste your data? I think you need to use that column.
That
Second
same
See, you have to
column you need
copy
to
and paste it.
Yeah, I
Muralidharan, you have to
pasted.
copy and paste it.
Yeah, copy in the Excel. I copied and pasted in the mini tab
Yeah.
in the C7 and C8 only. And pages type was available. But when we do that control chart attribute, only that the previous chart C4 and C5 only is coming. Should we refresh or
There is no
C1,
need.
C2, C4, C5? That
You
C7
don't
and
have this. Then let us try once again. Control charts. I don't know where it's wrong for you.
yeah, that is okay.
See,
Till then, okay. Now the C7 and 8 in the box, it is not coming. In the left side, that box. Here, I am getting only C4 and C5, that old data.
Okay. Or
Even though,
Muralidhar, you can do one thing. You delete all the things. Only you copy that part only. Pages and typo
you
copy.
can delete everything from C1 to C8.
Yes.
Okay, copy
okay.
that typos
Only
and
copy.
pages.
Yeah,
Yes,
yeah.
no.
1 minute. I'll do that.
Then you get.
1 minute. Now I'll try. Start. Control chart. Attribute chart. U chart. It is empty actually. U chart area is empty.
Okay, now copy paste that.
No. How? Like in that this U chart box is empty. I have retained the 7 and 8. Okay, if you want, I can delete and I can freshly copy the 7 and 8 also. Okay, 1 minute.
Okay, so copy paste and 7 and 8 in column numbers 1 and 2.
Yeah. 1 minute. Just give me 1 minute. Copied. Yeah, copied, sir. 1 minute. Stat. Control chart. Attribute. U chart. 1 and 2 is coming. So this typo will be variable. Typo is variable.
Typo is variable and subgroup is pages.
One subgroup is pages.
Now you've got a chart like this, right?
Invalid input column, too few items.
Yeah, you got it, or you have some error?
Yeah, 1 minute. Yeah, that is the same. Thank you. Sorry, sir, for that.
No.
All
of you must be able to do it. All of you must be able to do it. That is our
same thing. Getting. I don't know where some errors come. Yes. Now it's coming.
There is a possibility that your laptop might have created some difficulties.
Yeah, now
okay, guys. Yeah. See, all the data can be generated. C chart. Okay, RC or U chart. Yeah, but you have to ensure that the data is correctly pasted and the correct options are chosen. That only will help you to get the chart. Otherwise, you may be getting error. Okay, so here you can see there is some fluctuations beyond the limits, upper control limits. So you have to cross check this. That is the only thing you have to cross check it. That is why we are drawing this control charts, right? Okay. So in this case also 2 times on 2 samples, the data seems to be above the control limits. Verify everything. Verify all predictabilities. Verify the data for operator error, for operation gauges, error, data sheets. Everything must be verified. And if there is anything wrong in that, correct it and ensure standardize it so that no such errors are happening in the future in the data collection. Okay.
Any comment in that the test result for U chart of type, there's some test 1 point more than like that comment is, should we go there other than this graph? That comment in that mini tab, no sir? That also we should be go through or
yes, you can check the commands also, and you can, if you want, you can find out, you can interpret that also. That is
like how we are seeing the p value, for the LHR. Yes. Similarly, there are some comments there.
You can, yes. Yeah.
Thank you.
That is applicable for all charts. This abnormality is applicable for all charts, not only for P chart. It is applicable for all type of charts. Any type of chart you have the data like this, or like this. Your job is to check whether it is correct or not. See, in day one, I have explained to you about the importance of measure phase. That is, if the data is wrong, you may be making wrong decisions. So here also you have to ensure that the data is correctly collected. If there is something wrong in the data collection, then the chart you are generating also will be incorrect. So it might lead to wrong decision. So our objective is to ensure that you collect the data properly. Suppose if something is wrong in this chart, then you go ahead and cross-check the data first for reliability, for credibility. Then if the data is correct, then you can completely rely on this charts. Okay. That is what we are going to do first. So whenever we have some data fluctuating out of control, our first job is to ensure that the data collection is procedure, operation definition is correct, operator is aware of the data collection procedure, sampling technique is correct, no grouping, no tampering, no malpractice, no fabrication of data is present there. First, you ensure that. Then you can focus in the process. Okay, that is why we are using this data charts. Okay, control charts. Okay, now let us go for the another chart. What is that? That is the C chart. So when you have the fixed sample size, you are going for C chart. Okay, when you have a variable sample size and you are going to deal with defects, you have to go for U chart. When you have fixed sample size and you are going to deal with defects, you have to go for C chart. Similarly, the C chart is also having formula, central line, upper control limit, and lower control limit. Okay, now let us take this example. Okay, see, a company is manufacturing wallpaper. They are printing wallpaper. Okay, and they want to assess the stability of their printing process. Okay, samples of 100 feet are taken from 25 wallpaper rolls. So they have printed a lot of wallpapers, and wallpapers are present in the warehouse. So they are selecting 25 wallpapers, and in the 25 they are choosing 100 feet. Okay, so in all the 25 bundles, they are taking only 100 sheets, and they are checking for different kinds of defects like blemishes, okay, print spans, pattern distortion, missing ink. Okay, all these kinds of defects are taken. Okay, and they are going to generate a chart. Okay, now okay, let us go for the sigma level calculator. In that, you have the last example, right? Sample and wallpaper defects. Guys, copy that. Paste it in C7, sorry, C9, and sorry, C10 and C11. Again, go for statistics, control charts, control attribute charts, then C chart, then variables. In that, variable defects, no need to enter the typos, sorry, no need to enter the samples feet because it will be taken directly by the Minitab. Now click on OK. Guys, got it? All of you? What happened? Everybody is silent.
Yes, sir. Got it. Got it, sir.
Yes, sir, got it.
Yes, actually, Vignesh has asked a question. Why the upper control limit is having a zigzag? See, Vignesh, actually, I think you are asking about the variable charts, right? The
Yes, sir.
samples collected are not same. The samples collected are not same. Okay, the samples you are choosing every time is different. It is not going to be the same. That is why you are having a zigzag control line, zigzag upper control line. Okay, got it? If the samples collected is constant, we'll be having a constant upper and lower control line. The samples collected, if the samples which you are inspecting is, if it is varying every time, then you'll be having a varying boundary. That is what it means.
Thank you, sir.
Anybody is not able to generate the C chart?
Done, sir.
Anybody having difficulty, guys? Anybody having difficulty?
No, sir.
Okay, now let us go for the X bar S chart. We go for one more variable data chart. Okay, you believe you might not have done this. Guys, have you gone through this variable data chart? This one X bar S chart? Have you done it previously?
No, sir.
Okay, then we will do that. Okay, so far what we have seen is the attribute data, that is data based on count, defects and defectives. In that we have for defectives NP chart, and for defectives NP and P chart, for defects C and U chart. Okay, so now we will go for this variable chart. Another variable chart, okay, we have already seen this X bar R chart. That is when the samples which you are collecting and inspecting, if it is less than 8 or 8, then you have to go for the average and range chart. When the samples which you are collecting and inspecting, if it is more than 8, you have to go for a X bar S chart. That means average and standard deviation. You might ask, sir, why you go for standard deviation? Because when the population size is more, you will tend to collect more samples. Okay, in that case, the standard deviation alone will be a correct interpretation of your population measure. Okay, that is, for example, let us say a company is manufacturing 1,000 components. If they are inspecting only 10 components, whether it will be a real interpretation, whether it will be a real measure of their quality? Yes, no, guys, you have to give me an answer. Company
Yes,
is
sir.
manufacturing 1,000 components. If they are inspecting only 10, well, it will be a correct sample size.
With respect to the confidence level, it will
If they are
vary.
inspecting only 1%.
Yeah, 1%.
1%. That is not a good choice because it is not a real representation of the population. Population is 1,000, but they are checking only 10. So obviously it is not a real representation of the population. But sample which you are choosing must be a real representation of the population. So for example, let us say there are 60 students in a classroom. If I am asking questions to 2 students and I am assuring that the topic is understood by the entire class, whether it will be correct? It might be a wrong interpretation, right? I have to ask at least to 5 or 6 students, 10%. Then only that interpretation, that is, that 6 will be the real representation of the entire class. If I am asking to 1 or 2 students, that might not be a real representation. So I have to ensure that proper sample size is selected so that the sample size represents the correct population. Okay, it should be a real representation. For example, if the sample size is 100, if you are choosing 10, it is okay. The sample size is 1,000, at least you must go for 50. Then only it will be a real representation of
Any
the
thumb rule
population.
is there, sir? Any thumb rules?
No, it is obviously no. There is no such rule. You have to choose as per your process. For process industries like chemical, textile, okay, other things it might vary. So see, actually, depending upon your QAP, you have to decide the sample size. Your QAP demands more stringent measures. You have to go for higher number of samples. Your QAP is a bit lenient, you can go for less number of samples. Okay, so you have to decide. So when the sample size you are inspecting, you are collecting is more than 8, go for X bar yes. Okay, here also you have a set of calculations. Okay, for upper you have 2 charts here. You have 2 charts already. You know about the X bar chart, right? X bar is average of average chart. For that you have to calculate the average and double average of averages X double bar, upper control limit and lower control limit. Here it is. Then for the S chart, standard deviation chart, also you have to calculate the center line, upper and lower control limit using the formulas. But we will go with the mini tab. Okay. So all of you can open this sigma level calculator. I think this thing is not present in the sigma. I have shared the chart, but in that there is no. I have shared your Excel sheet. I believe it is not in that, right? In that there is no. Let us check whether there is XBAR. Guys, all of you have this XBAR R chart, sigma level calculator, and that XBAR S chart with you.
So that Excel sheet is not unable to open that one sigma chart.
Okay.
Okay.
Then I will
Yeah.
do one thing. I will copy paste in the UCX chart and share it again. Okay, what I will do is I will share this sheet once again, okay, in the chat, so that you can.
Is it possible
Okay,
any
guys.
others can share that Six Sigma chart?
I have shared the chart once again. Use and CNU. In the CNU, you have the third one. Third sheet is a XBAR and S chart. All of you, please check it out. All of you, have you seen the attachment?
Yes, sir.
Okay. Now in that attachment, you copy the serial number, reading, and sorry, not serial number. Okay, you copy all the 4 columns. Reading, subject ID and glucose level. You copy paste it. That must be 180 data. There must be nearly 180 data. You copy paste. Column number 3, 2, 3, and 4. Paste it in C13 like this. So all of you have pasted it, guys. See, this example is about, see how wonderful are these charts. See, actually, see, if you go through the samples, you can see in a particular hospital, okay, a doctor is monitoring 9 patients. In a particular hospital, doctor is monitoring 9 patients. Okay, and they are provided some proper diet, exercises, routine, and lifestyle. So the hospital wants to monitor. Okay, so every day they are collecting the blood samples of the 9 people, like that for 20 days. Imagine, for 9 people, every day they are collecting samples and they are doing it for 20 days. So here you can see day 1. This is day 2, day 3. Like this, they are collecting for 20 days. So if the doctor wants to know any patients are deviating from the diet or exercise or not taking the medications, the chart will indicate that. That is how it is easy to monitor the subjects, easy to monitor the patients. Okay. So all of you have pasted it. Nice. Okay, now let us go for statistics, control charts for subgroups. In this, you have to go for control charts for subgroups and XBAR S chart.
One second, sir. Statistics.
Let me statistics, control charts for subgroups. First ones, that is second one. Variable charts for subgroups. Click on XBAR S, the second one. XBAR S.
Okay.
Okay. Now the variable is the glucose level. Variable is the glucose level. Subgroup size is the subject. Sorry. Actually, you have to enter the subgroup size. What is the subgroup size here, guys? How many patients are being observed? Guys, please listen. The
12,
glucose level is how many patients we are observing.
9.
9 is the subgroup size.
Yes.
9 is the subgroup size. Why we are choosing the X bar S chart? Because it is greater than 8. So in the subgroup size, you have to manually enter 9.
Okay.
You have to manually enter 9. Yes, all of you have it done it, guys.
1 second. The subject. 9. Okay.
Now
And
click on OK.
glucose 9. Glucose. Yes, sir. Got it.
Others, Suresh, Muralidharan, have you got it, guys?
1 minute.
Yes, sir.
Glucose level. Yes, sir. Same.
Okay. So now, remember, the doctor doesn't have to verify the data every day. If he just checks the data on the 20th day, you can see if anybody is deviating or if anybody is not following the routine, it can be found. Here on the 10th day, you can see on the 10th day, there was some fluctuation. So what he will do is he will just pull the 10th day data and check any patients have more glucose level. Then he will check with that particular patient's glucose level, particular patient's diet and routine. And he will ask him to come and go for a counseling, whether he has deviated or whether he has not followed the diet. Okay, so that is how you can find out the deviation easily without going through the entire set of data. You can just predict the data. You can find out the data where it fluctuates, and you can just pull the data on that particular day more specifically, and you can cross verify it, and you can find out the reason. Very simple. Got it, guys? Got it, guys? That's it about the control charts for attribute and variables.
Variable chart.
Yeah. So if you have any questions, you can ask.
Generally in the industry, sir,
Yeah.
mostly we'll be focusing on out of control only. Within control, people generally,
yes.
because for that itself, they need to put some manpower because everything involves cost. So there also we can see a lot of gap. Even if out of control, putting some resource for analyzing that, we need have some concerns. But within the, suppose some data within the control plan means people are comfortable. And as you told that re-verification, recheck, that is not a current, what you call, people are not aligned. Correct.
Actually,
practice.
see, this is to verify your process first. See, if
That's
your process is regularly going out of control, see, actually, this control chart here is carried out after you have implemented a solution. See, for example, you are getting a new machine. The new machine is supposed to have less errors. And
so starting of the any new process, that is, I agree, sir. Once it's a running process.
Similarly, if you are changing something in the process to reduce the cycle time or to reduce the rejections, and after that, how will you demonstrate to your top management that
that is clear.
Is working?
Yeah. Starting time, definitely we need to do multiple checks. Once it's proven and established, then that check need not be carried out.
Obviously, regularly you have to do it. We cannot say that the check is not required. The thing is, we want to ensure that the solution is successful for a longer time. See, actually, a large number of rejections doesn't happen in a single day. It occurs gradually. Today you may have 1. Then next week it may be increased to 2. Then it multiplies to 4, 10, 15. So after 1 year, the number of rejections may be 10%. So we doesn't want to have that kind of numbers. So if anything is going out of control, not, you doesn't have to change too much of variation. You can, in the initial stage, you can control it easily.
Okay.
The final stage only you have to go for higher manpower, new infrastructure. So when you ask for that kind of things, your management will be questioning your ability. So to avoid that, if you monitor your process regularly using control
Regularly,
charts,
daily monitoring is must.
yeah, regular monitoring is must. Then you can and then you can identify the problem initially, and you can put
Yeah,
a remedy there, countermeasure it, and you can resolve it. Yes, Vikash, what is your question?
Yes, sir. Sir, during the initial stage, we actually pasted all the three columns like reading, subject, and glucose level.
Yeah.
But I tried pasting only the subject and glucose level, but it showed the same chart. Is it really necessary to copy and paste all the three like columns?
To paste only the subject and subject and glucose, there is no variable. Actually, only the glucose level is a variable.
Okay.
Yeah, only the glucose level is a variable. Suppose if I deleted the subject, actually the glucose level alone is enough, because the glucose level alone can be enough to generate it. Okay.
Got it.
Okay, explore, yes. And obviously the subgroup size is being entered by you because you have chosen the sample size. Okay, you have chosen the sample size. You are not giving any space. You are not choosing it from the table. You are entering the subgroup size.
Yes.
Because it can be more than 8. Yeah, the main variable is the glucose. See, for example, the glucose level informs you whether the patient has followed the medications, exercises, routine, and lifestyle. If the glucose level here it is 165 before fasting, before eating, so it indicates he might not have followed the medications or routines or exercises. So instead of going through the chart every then and there, if you plot a graph, if you plot a control chart, it informs you when the patients are not following it. So the doctors will be having an easy time in predicting the patients who are not following the diet or medications. Okay, and they will just pull their records, call them, counsel them, and ask them to insist them to compel them to follow it. So here, see, in all process, you can anywhere, wherever you have more samples, okay, to inspect, you can use this kind of charts. Got it, guys?
Yes.
Okay, any other questions? Or we will break for the day.
Siddharth,
nice day.
somebody is posted some message in the chat.
Christina. Okay,
Siddharth.
Sir, not understanding the subgroup size is 9. Subgroup size. What is subgroup size? Here, we are taking 9 patients for samples. 9 patients glucose level are collected every day. That 9 is the subgroup size. Subgroup size means sample size. Sample size or subgroup size, both means the same. Siddharth Vishwas, are you able to understand it? I think Siddharth Vishwas is not. Yes, he is in the. Okay, he got it. He has replied in the group.
Yeah, okay.
Yes, guys, remember in the mini tab it is subgroup size. It is not sample size. But the general term which we use in our organization company is sample size. Okay, that is why you are having a doubt there.
Yeah, thank you, sir.
Okay. Okay, guys, have a break then. We will meet next week.
Thank you, sir. Have a nice day.
Yes, bye. Thank you.